In this example, we're going to look back to Intermediate 2 or National 5 trig applications before we go into higher ones. So in this first example, the mass of a spring oscillates according to the formula here, h equals 6 plus 4 cos t, where h is meters and t is in seconds. What is the maximum height of the particle? What is the minimum height of the particle? Calculate h when t is 45 seconds and calculate t when h is 7 meters. So 4 different questions here. Now, to calculate the maximum and minimum heights, what we have to think of is how cos t changes over time. And if you think of the cosine wave, the maximum value it hits is 1 and the minimum value is -1. So if we look down at the solution, the maximum height occurs when the cos t is at its maximum, which is equal to 1. So what we do here is we replace cos t with 1. So the equation becomes 6 plus 4 times 1, which is 10. And that's the answer to part 1. To find the minimum, the same thing applies. The minimum value occurs when the cos of t is equal to -1. So if we substitute -1 into here, you're going to get 6 plus 4 times -1, which is 6 take away 4, which is 2. That's how you find the maximum and minimum values. For question 3, calculate h when t is 45. Well, you substitute 45 in here and then work it out. So it becomes 6 plus 4 times the cos of 45. In Intermediate 2 or National 5, you would be allowed a calculator for this and you multiply it out and it would come to 6 plus 4 times 0.7071 and you get 8.83. To calculate the last part, solution 4 if you like, calculate t when h is 7. Well, you substitute 7 in here and that forms a trig equation and then you solve it. So substitute 7 in and solve the rest. I'm not really going to go through that. You can have a quick look at it here, but it's just a straightforward trig equation.